So let's add an explicit animation. And for that, I'll go to the categories screen where I have this grid view, where I display a grid of category items. So in the end, I'm talking about this screen here. I want to add a little animation to that screen that lets these category boxes, these category items, slide in from the bottom whenever we load this screen. So when we, for example, get to this screen from the favorites screen, or if we just started the app. And such a slide animation could be built by adding our own custom explicit animation to this categories screen. Now to do that, we first of all have to convert this categories screen class here to a stateful widget. And for that, we can right-click on stateless widget and choose refactor and choose convert to stateful widget. Because if you're adding an explicit animation to a widget, you must add it to the state object of that widget. So you must be working with a state object, because behind the scenes, an animation sets the state and updates the UI all the time as long as the animation is playing, which is why it needs such a stateful widget so that it can update some state behind the scenes and re-execute the build method. That's the idea here. Now, with this changed, you can go to your state class, and here you first of all have to add something. And in there, you can now create a new property that could be called _animation controller. The name is up to you, but in this property, we are ultimately going to store a value of type animation controller. However, this animation controller can't be created here where the property is initialized. Instead, you should use initState for this. So you should add this initState method, about which you already learned earlier in the course. And in this initState method, you can then create this animation controller. Nonetheless, this animation controller must be set before the build method executes. And to tell Dart that this property doesn't have a value initially when the class is created, but will have one before it's really needed, you can add a special keyword in front of animation controller, which we haven't used up to this point. You can use late, the late keyword. And this tells Dart that this in the end is a variable which will have a value as soon as it's being used the first time, but not yet when the class is created. So that there simply is a little timing difference between when this property is created technically and when it will have an initial value and when it will be needed for the first time. With late, you tell Dart that it will be fine. Once this property is used, it will have a value. Now, speaking of a value, you should still set the type of value that will eventually be stored in here after late, before the property name. And the type here will be animation controller, which is a type built into Flutter. To be precise, it's a class provided by Flutter, and as you learned in this course already, every class brings its own type. Now we can initialize this animation controller in initState. So then it will be ready before build is executed, but as mentioned, not right away when the class is created. But that's fine because of late. So here in initState, we can now set animation controller equal to animation controller, using that class provided by Flutter to create an object based on that class. And now this class's constructor function offers a bunch of configuration options here. And there is at least one option, vsync, which we must set. Now vsync wants a so-called ticker provider. In the end, this vsync parameter is responsible for making sure that this animation executes for every frame. So typically 60 times per second to overall provide a smooth animation. For this, it must be set equal to such a ticker provider, and this ticker provider is actually received by using another special feature offered by Dart, which we haven't used up to this point, and which, to be honest, you typically don't have to use that often, but you do need it here for explicit animations. You should add the with keyword here after extending this state. And that's another keyword built into Dart, a keyword which allows you to add a so-called mix in to a class, which you can think of another class being merged into this class behind the scenes and offering certain features to this class therefore. And the class that should be merged in here is the single ticker provider state mixin, which is provided by Flutter. And behind the scenes, this class, which we're merging into our class here, simply provides various features that are needed by Flutter's animation system. By the way, if you had multiple animation controllers and not just one, the right choice here would be the ticker provider state mixin like this, but if you only have a single animation controller, it is recommended to use the single ticker provider state mixin instead. Now with this added, the value for vsync should be set to this. So to this entire class, which now has this ticker thing merged into it, and therefore behind the scenes, this animation controller will be able to get this frame rate information which it needs to fire our animation once per frame. So for example, 60 times per second. That's what we're setting up here. Now, in addition to vsync, which is always required when creating an animation controller, you can also add a duration to control the duration of the animation you want to play. And for that here, you can create a duration object by using Flutter's duration class. And here I'll set my duration to, let's say, 300 milliseconds. And of course you can play around with that value to control how long this animation will play. So this animation where I want to slide up my grid items here. Now, besides the duration, you can also set a lower bound, for example to 0, and an upper bound. And with that you will in the end control between which values Flutter will animate. And this might sound strange, but it's important to understand that with animations, you in the end always animate between two values. For example, 0 and 1. And then it's your job to translate these values into something that changes something on the screen. For example, you could be adding some margin or padding to a widget, and that margin or padding could be based on the current animation value, which is between these two boundaries. And the animation controller will automatically move between these boundaries during this duration. And if this is still a bit abstract, you will see it in action in just a second. By the way, these settings here, 0 and 1, are the defaults and don't need to be set, but you can of course also set them explicitly if you want to, or set them because you want to animate between different values, like 0 or 20. Again, it will depend on what you plan to change based on these values. So here I'll stick to these values and explicitly add them even though they would be the default. But now with that we have an animation controller which we can use to play the animation. However, that's not all we have to do. Besides now using this controller, which we'll do in a second, we also should add this pose method here, which is another method built into Flutter widgets, which is called automatically behind the scenes, but which you can override to then still call the parent widgets method behind the scenes, but to then also perform your own cleanup work. And here I'm using this pose to use my animation controller and call this pose on that. This makes sure that this animation controller is removed from the device memory once this widget here is removed, to make sure that we don't cause any memory overflows or anything like this. And now with that, we're ready to use this animation controller to actually change some values that will have a visual impact.